All right, eighth graders, we are looking at page 71 in your math binder. It's called Linear Functions. So this paper should be on your desk. And what I want you to do first is I'm going to have you push pause, not just yet, in a second, but you're going to push pause and the directions say circle the letter next to the graphs that you think are linear. Now, if you remember your last lesson, Ms. McGowan talked to you about what it looks like in a graph for something to be linear. So if you can't remember, maybe look back at those notes and see what she said and circle, like if you think that A is linear, circle A or B or C or whatever it is, because we're going to go over that once you push play again. So pause, circle the ones that you think are linear. Okay, let's go over these. So if you look at A, you can see that there's a dot here, 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 and here. And if I were to take my straight edge, I could line it up and those go perfectly in a straight line. So A should be circled because A is linear. B curves, so it is not linear. Do not circle B. C has a straight line, but then it has a corner and it goes into a straight line in a different direction. That is not linear. D curves up, down, and back up. That is not linear. E is a straight line. Circle E, it should be linear. F, they are lined up in a straight line. That is linear. G curves down and back over, not linear, do not circle it. H curves up, kind of like one of those ones we saw last week. And I'm guessing, I think that's an I. It kind of looks like an, yeah, I guess it would come after H. I. You can see that this changes directions multiple times. That is not linear, do not circle it. So we only had A, E, and F that were linear. So over here in the margins, what do I know about graphs that makes them linear? So I'm going to twist my paper sideways and I'm going to write the word graphs. So when a graph is linear, what do we know about it? What does it look like? Well, they are straight lines. If a graph is a straight line, then we are going to say is linear. That feels like the worst grammar in the world. Straight line is linear. Yes, it is. If it's a straight line, it is a linear graph. Okay, now you are going to look at these tables. Now the table is not quite as obvious, but I would like you to just take your best guess. Hopefully you're using pencil on this first part because if you have to fix your answer, we'll do so in just a moment. But I would like you to circle the letter next to the table that you think are going to be linear based on whatever you see in the table. So push pause, circle any of the ones that you think are linear. Okay, we are going to start with that first table there, A. So I'm going to begin by checking something. I'm going to check with my little swoops, remember those fancy things that I love to talk about? How do I go from -5 to 0? Well, I'm adding 5. And then up above it, how do I go from 0 to 1? Well, from 0 to 1, I'm adding 1. So whenever I add 5, I add 1 on the other side. Let's look at this next one. From 0 to 5, I'm adding 5. And from 1 to 2, I'm adding 1. So far, my slope has stayed the same. I had 5 over 1 and 5 over 1. We also call that a rate of change. So this is changing at the same exact rate. Let's check the last one. From 5 to 10, I'm adding 5. And from 2 to 3, I'm adding 1. So I always had the same slope or the same rate of change here. I always changed 5 up, 1 to the right. Now, if I'm always going 5 up, 1 to the right, 5 up, 1 to the right, 5 up, 1 to the right, that's going to be a straight line slope. So what we know about these tables is if we have a constant slope or what we call a constant rate of change, where it's always the same y value and x value, or they can reduce to the same y value and x value, then it's going to be linear. So you are going to circle A. Let's look at B. On B, this one's got a decimal, so some of you might have just skipped it because decimals feel really scary. But I promise you, they're not that scary. So how do we go from 15 to 12.5? It's subtraction. We know we're subtracting 2 to get to 14, or sorry, to get to 13, and then half to get to 12.5. So that would be minus 2.5. Then how does the x value change? Well, it's adding 1. Then I can subtract 2.5 again, and up here, add 1, because that's what's happening. So far, we've had the same rate of change twice. That's looking good. Then from 10 to 7.5, we are subtracting 2.5. And from 2 to 3, we are adding 1. 8th graders, we had negative 2.5 per 1x, negative 2.5y per 1x, and negative 2.5 per 1x. Circle B. That is also linear. Okay, let's look at C. If I look at C, I need to go from 4 to 8, which is adding 4, and from 0 to 1, which is adding 1. Okay, then how do I go from 8 to 16? Well, I have to do 8 plus 8. Uh-oh, anybody else feeling nervous right now? The only way this is going to work is if the other side is a 2, because we know 4 divided by 1 would equal the same thing as 8 divided by 2. However, to go from 1 to 2, you add 1. So do we see how our rate of change changes? It was going up 4 to the right 1, and now it goes up 8 to the right 1. It got steeper. So this one, not linear. It was a non-linear graph. I don't think you have to cross it off. I don't know why I did that. I felt really strongly about it. Let's look at D. So now that you've seen how I make these swoops on here, try filling in those swoops for D. Let's try to fill them in. How do you go from 98 to 98? What are you adding? Nothing, so plus 0. And up here, 0 to 1, you're adding 1. Okay, from 98 to 98, you are adding 0. From 1 to 2, you are adding 1. And then from 98 to 98, you are adding 0. And from 2 to 3, adding 1. Beautiful. Always 0 over 1, 0 over 1, 0 over 1. That totally works. That's actually a flat line. Up 0 to the right 1, that is going to be linear. Okay, let's look at E. On E, you go from 3 to 2, which is subtracting 1, and then from negative 3 to negative 2, which is adding 1. Then from 2 to 2, which is adding 0, not looking good. And then from negative 2 to 2, which is adding 4. Definitely not looking linear because our rate of change changed. I like saying that phrase, my rate of change changed. Okay, then F. From 2 to 4, I add 2. From 1 to 3, I add 2. And then from 4 to 6, I add 2. And then from 3 to 6, I add 3. Ugh. Not the same rate of change because I have 2 per 2. So I'm going up 2 to the right 2, which would reduce to 1 over 1. And then I'm going up 2 to the right 3. That's a different slope, different rate of change. It's not linear. Okay, let's look at G. I know these ones are a little bit more work than just looking at a graph. Sorry. Okay, so for G, I have from 4 to 5, I'm adding 1. The nice thing about the nonlinears is I can stop once I see that it's nonlinear. From 2.1 to 2.2, I'm adding 1.1. Decimals! Okay, now that we got that out of our system, let's look at the next one. 5 to 6 is adding 1. And then 2.2 to 2.3 is adding 1.1. From 6 to 7, I add 1. And from 2.3 to 2.4, I add 1.1. So I'm always going up 1 to the right 1.1. That rate of change stays consistent the entire time. So circle G. That is linear. Okay, let's look at H. 4-letter H. From 2 to 6, I'm adding 4. And from 0 to 4, I'm adding 4. From 6 to 18, I add 12. And from 4 to 8, I add 4. So if I divide these, up 4 to the right 4, that reduces to 4 divided by 4, which would be 1. But then up 12 to the right 4, that would reduce to 3. 12 divided by 4 is 3. That is not linear because your rate of change is not the same proportion the entire time. It does not stay the same reduced fraction the whole way through. Okay, let's look at I, J, K, and L. I'm going to have you push pause And I want you to try to fill in the rest of the tables for I, J, K, and L. Check your work, and then I will go over it on here. Okay, 20 plus 4 gives me 24. 3 plus 3 gives me 6. 24 adds 8 to get to 32. And then 6 adds 6. Now you might be tempted to say not the same rate of change, but let's look. Up 4 to the right 3, that reduces to still up 4 to the right 3, but up 8 to the right 6, that would need to be reduced. So let me explain that a little bit better. If you have 4 over 3, that is equal to 8 over 6. Those are the same fraction. One of them is just reduced. So far, we're actually pretty good here. 32, to get to 48, you have to add 16. And from 12 to 24, you add 12. If I do 16 divided by 12, that would reduce to the fraction 4 over 3. This one is linear. It's always the same slope. That 4/3 is always the repeated slope. Because remember, slope is always change in y divided by change in x. Okay, for J, we are going to go right here. We're subtracting 20. And up here, we're adding 20. Negative 20 over 20 would give us a change of -1 for our rate of change. And then I subtract 20. Add 20. And then right here, from -60 to +80, that goes up 140. I don't know where that comes from, but I'm guessing they were banking on you not checking the very last thing and saying, oh yeah, this is definitely linear. This one's not linear. That random plus 140 is outrageous. Okay, let's do problem number K. I forgot that it was a letter once I got to the word number. From 0 to -1, I'm subtracting 1. And from 5 to 10, add 5. -1 to -2, subtract 1. Up here, add 5. Down here, subtract 1. Up here, add 5. That is definitely linear. You always had the same change in y over change in x. Last, but certainly not least. From 4.2 to 8.2, I am adding 4. And from 5.1 to 6.7, I am adding 1.6. Right here, I am 8, 9, 10, 11, 12, I'm adding 4. 13, 14, 15, 16, I'm adding 4. So we know that it's always adding 4. That does not make it linear until we check the top part. 6.7, 6.8, 6.9, 6.10, 6.11, 6.12, 6.13, and then, or 7.13, and then, oh my gosh, just ignore me. I'm doing decimal math in my head, but it does actually add 1.6. And if you would prefer not to listen to Miss Johnson's gibberish counting, you can also do this on a calculator. 8.3. And if we try adding 1.6, we get 9.9. So that same change in y over change in x makes this L linear. All right, that was a fun section. Our last section, I would like you to make your initial guesses. Oh, before we do that though, twist your paper sideways and we are going to write a note about tables. So over here, we're going to say table. I'll make it plural, I'll put an S after it. We are going to say change in y divided by change in x. And for those of you who remember the shorthand way to write that, it's triangle y, triangle x. So change in y over change in x equals constant number. If you get the same number for your change in y divided by your change in x, then it is going to be linear. Okay, one last section. Our last section is going to be equations. So you are going to circle any of the ones below that in your heart you think would be linear. So this is just an initial first guess. I promise we'll talk about them. in just a moment. Feel free to use desmos.com, by the way, if you would like. Okay, so we are going to, actually, I'm going to open Desmos on this computer. Okay, so we are going to start with that first one, the 2x plus 4y equals 16. Now, it looks a little different than some of ours where we had like y equals mx plus b. So I am going to switch and show you what it would look like if we were to graph that. So if I open up my Desmos calculator and I type in 2x plus 4y equals 16, I get this lovely looking straight line graph. So my straight line would say that this thing is linear. So let's go back to our paper. And because it was a straight line, we are going to circle it. That was definitely linear. Okay, let's look at another one. The second one, we're going to type it into Desmos. And I can X this off, or you can delete it off by backspacing. You could also go to a new line and graph another one, but then you're going to have like 100 graphs on there. I suggest that you get rid of it. So our second one is y equals, and then we have that really funky absolute value. If you don't know where the absolute value is, I'll give you a quick reminder. Down here in the bottom left corner, click this show keypad. And do you see how it says this absolute value right here? We're going to click that, absolute value. And then inside those absolute value, we have our 2x. Then I have to push this absolute value button again. That's already looking like a super fun graph. After that, we're going to put, not minus, we're going to put plus 5. If you ever can't see really well on this, you can zoom out or you can zoom in, but this one, definitely not linear. That's not a straight line. So I'm going to go back to my paper and I can show that this one was not linear. So I'm going to not circle this next one. It was not linear. And we'll talk about why it wasn't linear once we get done with all of these. So if you haven't already, again, we're checking these on Desmos, but let's type in this next one. And I will, instead of flipping back and forth every time, I will stay on the Desmos screen after this. So we're going to go through each of these one at a time. And we're going to check them on Desmos. And if they're a straight line, we're going to circle them. The reason that I'm going to stay on one is because I am getting confused flipping back and forth. Okay, so that was the second one. Let's go to C. C is y equals x. And then we go down here. There's the squared button. You also could use this button just to get any exponent, but I'm going to click squared. And then you have to push over because you don't want to accidentally do plus 5 up. Oh, it brought it down anyway. So we have x squared plus 5, definitely not a straight line. Do not circle C. Let's check D. D, we have y equals 5, and then we've got times 3 to the power, this little power button, a to the b, of x. E, that is not a straight line, my lovely 8th graders. That is a curved line. This is that line we were talking about where it looks like it gets infinitely close to 0, because it does get infinitely close to 0. It's crazy, but we are not going to circle D. So we've only had one linear answer so far. It was A. Let's try E. All right, so E, we have y equals, and then to make my fraction, we can click on functions here. You can also use like the, nope, you do not have it there. Is there a better way to do fractions besides just the over? I don't think there is. Okay, well, we'll just use our backslash button or just regular slash button. So we've got 4, and then I go over by using the thing next to shift, x. Oh boy, did you see what just happened to that graph? Then we're gonna, instead of putting plus 3, you don't want to put it on the bottom. You want to go over to the right, and then you can type in your plus 3. That is a bizarre graph. I actually love these graphs. They're some of my favorites. They're so beautiful. Not linear at all, because it's not a straight line. It curves. So that one was not linear. We're going to move on. Do not circle E. F looks kind of similar to E. The only thing that F does is it flips around the X and the 4. So right here, instead of 4 over x, it's going to be the 4 in the denominator and the x in the numerator. Isn't that so crazy? Look at that. That's a straight line. So literally when we flip the fraction like that, it goes nuts. But when we have it flipped this way, it's a straight line. So on your paper, you are going to circle F. Not E, F. Okay, let's type in G. We'll cross off this one. And for G, we have y equals, and then I'm going to find where square root is. It's right here. Square root of 4x. And you can see that's not a straight line. Do not circle G. Let's type in H. H is x squared plus y squared equals 25. We just made a circle. Congratulations. That's how you make a circle up here on a graph in math. Is this linear? No, a circle is not linear. Do not circle H. Okay, let's go to I. I is x, y equals 24. This one seems pretty nice and normal, and it is not. You can see that it's got this like double curve thing again. Do not circle I. Okay, let's go to J. J is 2x plus y equals 6. Straight line. Please circle J. All right, let's go to K. Y equals negative 2/3 x. K is a straight line. Please circle K. All right, we're going to go to I, or that's not an I, that's a KL, I guess. And it is just y equals 8. You can see this red line goes straight across. It's a horizontal line, but that is still a straight line. So you have to circle L. All right, let's type in M. Y equals 2/3 to the right x. So this is the positive version of K, and it's still a straight line. So we are going to circle M. And let's go to N. Y equals x to the power of 3. Ooh, that's an adorable little switchback in the middle there. That is not linear because it is not a straight line. Let's go to O. 3x minus y equals 2. That's a straight line. Please circle O. Weird to circle a circle. And lastly, P. Y equals x parenthesis x plus 2 parenthesis. This one, do not circle it. It's not a straight line. I want to show you what all of our linear ones looked like on our paper and what all of our nonlinear ones looked like. So let me show you my paper again. On this bottom section, you'll notice that the ones we circled were kind of boring looking actually. 2x plus 4y equals 16, y equals x over 4 plus 3, 2x plus y equals 6, but they all had like an x and a y that looked fairly normal, and they had fractions sometimes. Sometimes they had numbers in the denominator, but we know x over 4 could also be written 1/4 x. So again, not too crazy. Almost all of those could be easily solved for y, and they would look like y equals mx plus b. So we know it's linear if it looks like that. So which ones made it not linear? Well, let's check out some of the weird things that happened on the nonlinears. So one of the weird things happens on B, these absolute values. So if you have absolute values, I'm going to put a little star down here and I'm going to say non-linear weirdness. So whenever any of these weird things happens to x or to y, you are going to know that it is a nonlinear equation. So one of the nonlinear weirdness things is when there are absolute values. And that's just when it happens on the x or the y. But if there are absolute values, then it is not linear. Okay, on this one, what do we notice about the x? It's squared. And there was another one. This one has x and y squared. And then there was one over here that had x cubed. So anytime there are exponents on your x and y, I'm going to say non-1 exponents. Those are the weirdness. Okay, those are going to make them nonlinear. Okay, what else is weird here? Okay, this is also a non-1 exponent. It puts x in the exponent, like super weird. Okay, let's look at another one. This one has a square root. Square roots are weirdness, and they are going to make it nonlinear. So square root. Which other ones do we have? Okay, this one, it's multiplying x and y together. So we're going to say x times y. Or over here, it was x times x when we distributed that. And one of the last weird things we had, so this was weird, this was weird. Whenever you have a variable in the denominator, so I'm going to say x on bottom. That's going to give you weirdness that makes it not a straight line. So all of those things will make this nonlinear, and hopefully you can look out for those. Another really great thing to do if you're trying to test if a graph or a equation is nonlinear, graph it, see if it's a straight line or not. All right, let your math teacher know if you have any questions.